This paper 1 consists of two sections, section 1 and section B. But we shall go through numerical problems and the derivation, and for explanation or conceptual questions, we'll be just giving the highlights or hints of the problem. Now let us start. Questioning Physics 1, section A. This section is having total number of questions 7, each carrying 10 marks. So we start with question number 1, part A, Roman 1. The question is, which quantity in a given formula should be measured most accurately, and explaining why. So, which quantity should be measured more accurate in a given formula? In the measurements, the quantity which is supposed to be measured with more accuracy is the one which having the highest degree. That means the power degree, if you have a formula maybe P equals to A X Y, Z. Then these are the powers, X and Z are the powers. Then if the largest power, if X is the greatest power, then quantity A should be measured most accurate. The reason why, because the error in A will be multiplied by its power. Error in A will be multiplied by its power. That means error in A is equal to by X. This is the reason why the quantity with the greatest power should be measured more accurate. We move to part 2. Part 2, the question says, Explain the difference between the least count and error. Of course, this we don't need to write, just explanation. Count is the smallest possible value that is display accurate, or an instrument can measure accurate. But error is just a deviation from the truth value, or just a difference between the true value and the measured value. Part B, or Part A, Roman Ferre. This is a numerical problem. We have been given the viscosity of a liquid flowing through a capillary tube of length L and radius R as given by formula. So we have been given a formula volume over time equals to pi R exponent 4 pressure 1 minus pressure 2 over 8 eta times L. This R is the radius of the pipe. This is the pressure at one end of the pipe. This is the pressure at the other end of the pipe. This is the viscosity coefficient of the fluid flowing in the pipe, and L is the length of the pipe. Then the question is, find or write the value of eta, including its associated error. So we have been given the values of each variable there. L is given as 26.00 plus or minus its error 0.1 centimeter. Radius of the pipe is given as 0.6 plus or minus its error, which is 0.01 times 10 raised the exponent negative 2, this in meter. The pressure P1 is given as 8.1 plus or minus error, which is 0.05. All of this times 10 raised the exponent 10 raised the exponent 3. This in Newton per meter square. Pressure 2, (5.4) plus or minus 0.05 times 10 Newton per meter. And the last is, we have the volume equals to 3.2 plus or minus 0.02 bracket, and this is measured in centimeter cube. The last quantity is the time. Time given as 60 plus or minus 0.2 second. So the question, we are supposed to find the value of eta. So first step is to make eta the subject from the given formula. That is eta equals to pi equals to pi r exponent 4 p1 minus p2 times t over 8 v naught l. Then, because we are looking for the value of eta, we can substitute the given data and find its value. Pi is given 1.4. R, here we have been given R 0.65 raised 10 negative 3 exponent 4 pressure is given 8.1 minus 5.4 times 10 exponent 3 and the time given is 60 seconds over 8 times volume. Volume is given as 3.2, but because volume is in centimeter cube, we have to change it into meter cube, so times negative 6 meter cube. Then length is given as 26 then centimeters, so it is 0.26 in meters. Then you get its value here by using your scientific calculator. You get the value 0.015. Eta is measured in Pascal second, or can be measured in Newton second per meter square. But the question not only to find the value of viscosity coefficients, is also to find its associated error. The error which will be resulted due to the error made during the measurements of radius, pressure 1, pressure 2, volume, and length. Therefore, the associated error can be calculated by applying natural logarithm to the given formula and then simplifying to get fraction errors. how apply natural log to this given equation. That means natural log of eta equals to natural log of pi r exponent 4 p1 minus p2 times time over 8 v naught L. From here you simplify your equations. That means you get eta equals to natural log of pi over 8 plus 4 natural log of r plus natural log of p1 minus p2 plus natural log of t minus the natural log so minus the natural log of v naught minus natural log of L. If you differentiate the simplified equation, you get the fraction error. Differentiate this equation to get fraction errors. That's the derivative of natural log is a change in physical quantity divided by its physical quantity. So from then change in y is equal to change in x over x. We apply this concept to differentiate these entire expressions. Therefore, change in this one over itself will be change in eta over eta equals to change. Here is the constant, therefore the derivative of constant is 0. 0 over this number is also 0. So this term vanish, remaining with the 4. Change in R over R plus the next is change in pressure 1 minus pressure 2 over pressure 1 minus pressure 2. And the next is change in T over T minus the next is change in V naught over V naught minus the last two, which is change in length over length. But because we are looking for the maximum error, we are going to maximize this fraction error. We are looking for maximum error. Error this expression will be maximized. We change all the negatives to be positive. So this over eta equals to 4 changing R over R plus, and also this, it is the error in the difference. I will define later what is error in the difference. Over P1 minus P2 plus delta of T over T plus delta of V0 over V0 plus delta in L over L. So now our expression is maximized. So this is the maximum fraction error because we don't have any minus in it. Likewise, also from definition, error in difference is equal to error in addition. So this is equal to error in P1 plus error in P2. So instead of having error, bracket P1 minus P2, we'll have error in eta over eta equals to 4 error in R over R plus error in P1 plus error in P2 divided by P1 minus P2 plus error in T over T plus error in V0 over V0 plus error in L over L. So we have all the errors. We can substitute in this part because we have error of every physical quantity. We substitute and then we get a fraction error. So from the given data, the error in R is 0.01. So it is 4 times 0.01. R itself is 0.6. Remember this in the data we were given also times 10 exponent -3. So although they are going to cancel, but it is important to substitute them so that everyone can understand how this vanishes. Plus error in pressure 0.05. The other pressure is also 0.05, but here pressure difference, don't forget this was times 300. Pressure difference is 8.1 minus 5.4 plus error in time to 0.2, the time is 60, plus error in the length, which is 0.1 over length, it is 26. So in simplifying, you get 0.119. The error has no, let me verify. So is it another one there? So this is a fraction error, and remember, fraction error has no unit because it's just a ratio of two quantity of the same units. But the question is, what is the error? So to get error, in eta, which is the change in eta, this is the same as taking this number times eta. Eta was calculated earlier, and its value was its value was 0.01. I guess it was 15, but it's not 15, it is 135. And this is having the unit Newton second per meter square. If you multiply this one, get almost 0.01 or it is 0.0151. This is Newton second per meter square. So how the question is, write the answer. The question is, if you go back to the question is write the value of eta. Therefore, the value of eta is equal to this value, which is 0.0135 plus or minus its stated error, which is 0.00151. All of this in Newton second per meter square. Or sometimes you can write 1.35 plus or minus 0.15 bracket times 10 exponent negative 2 Newton second meter square. The other part B, distinguish between systematic error and random error. Hence, it suggests one method used to minimize each type of error. Systematic error, these are the error occurring in the measurements due to known reason or known causes. While random error, these are the errors that occur in the measurements due to unknown causes. That means you cannot suspect the cause of those errors during measurements. The method used to reduce or minimize this systematic error is just using the proper calibrated and designed instrument or using improved method of measurements. But for random error, the only way you can minimize the error is by taking number of measurements or readings of the same physical quantity and eventually finding its average mean or arithmetic mean. For part C, explain 4 uses of dimensions. Actual dimensions are used to derive a formula of physical quantity. Dimensions are used to check the correctness of any given formula. Dimensions are used to find dimensions of dimensional constants that appear in the formula. Dimensions also are used to change or convert one system of units to another. All those are the uses of dimensions. The next is state the principle of homogeneity for dimensions. Of course, the principle of homogeneity for dimensions states that for any physical given or for given physical quantity is said to be dimensionally correct if and only if the dimensions of each term in either side of the given relation or physical equation are the same. When it's satisfied, then that is a principle of homogeneity. That any equation that you are given must have, each term must have the same dimensions. For example, I've been given equation A equals to B. Then, according to this principle, dimension of this term must be equal to dimension of that term. Or one side there is one term, the other side there are 2 terms. Then according to this principle, this equation will be dimensionally correct if dimension of this term equals to dimension of this term equals to dimension of this term. That means dimension of A equals to dimension of B equals to dimension of C and equals to dimension of B plus C. After that, we go to Roman 3. Roman 3, we have been given a formula. The stress SC required to fracture a solid can be expressed as S given S equals to K under root lambda E over B, where S is the stress. S is the stress, lambda is unknown, E is the Young modulus, and D is the diameter. Then the question, find the dimensions of physical quantity lambda and suggest the meaning of this quantity. So we have been given this one. That means that we are applying dimension to find the dimensions of this constant lambda. The first step is to make that lambda the subject. Therefore, lambda equals to S square D over E times another constant. or constant 1. Because if this is k, this is k1 after k squared. Then the dimensions of this lambda is equal to dimension of k1 s squared d over e. Then this is the same as dimension of k1, dimension of s square, then dimension of d over dimension of e. Then what is the dimension of S? We are told SC is a stress. Stress means force per unit area. So this will be equal to K is dimensionless, so we don't write dimension of S. It is the force per unit area. So it is ML minus 2, then it's square. Dimension of D is L, and the dimension of E, which is Young modulus, is the same as stress per unit strain, but strain has no unit, so just having the same dimension as stress. So on simplifying this one, this will cancel with the one of the m, because this will be m square L negative 2 T negative 4 times L over m L minus T negative 2. So one of the m will cancel out, or m 2 minus 1 L negative 2 plus 1 T minus 4 plus 2. So this is equal to M1. This will vanish. This will be T negative 2. So dimension of lambda equals to this one. Another thing here is, what is the meaning of this quantity? To know the meaning of this quantity, first you look at its dimension. This is the dimension of which quantity? By looking, this is the dimension of surface tension. So the meaning of this quantity lambda is, so the quantity, this lambda representing surface tension. We quickly jump to the next question, which is Roman 4. Roman 4, we have been given the velocity v of a liquid beyond which a streamline flow ceases and the turbulent flow begins. Depends on the radius r of the tube, density rho, and viscosity eta of the liquid. Using dimension analysis, obtain the expression which relate v, r, rho, and eta. So this is another application of dimension. That means we need to derive a formula that relates these two quantities. So, dear students, in order to derive a formula, you have to follow the following steps or procedures. First, you know what is the dependent variable and which one are independent variable. We have been given velocity depends on this velocity is dependent. Variable. And the independent variable have been given radius, rho, which is density, and the viscosity coefficient eta. These are independent. Independence. So procedure number 1, first let x, y, and z be the exponents of power for r, rho, and eta respectively. Then from the given information, velocity is proportional with the r raised to x, eta raised to y, rho raised to y, and eta raised to x. Then remove this sign of proportionality by introducing a dimensionless constant k, rx, rho y, eta z. Then, when we are deriving any physical equation or physical relation of physical quantities, we first assume this equation is dimensionally correct. So, suppose that this equation is dimensionally correct or obey our principle of homogeneity. Correct. If it is correct, that means the dimension of left hand side equals to dimension of right hand side. But the dimension for this left hand side, it is the velocity. So velocity has no mass. -1, but the dimension of the other side, k is dimensionless. So this is L, but is having exponent x. And this is density, this is mass per unit volume. Y and eta, it is m, L -1, T -1. Eta, for those who cannot remember, you can use the formula force or drag force equals to 6 pi r eta v, which is terminal. Then from this equation you can find the dimension of eta. Or from force between the two parallel layer of fluid is equal to negative eta area times the velocity gradient dx. And from this formula you can find the dimension of eta. After that, combine these variables, like variables together. That means m L t minus 1 equals to m, there are two m, mx, my, and mz. So my plus z. For L we have x minus 3y minus z. So times L x minus 3y minus z times the last, which is time. Here we don't have time, Here we have only one time, so times negative z. Then after writing in one variable, compare the power of each one. Compare the power of each side. That is the power of m and the power of m, power of L and the power of L, power of t and the power of t. In comparison, we start with it for m. The power on the left hand side is 1. This exponent is equated with the exponent of m on the other side, which is x plus, it is the y plus z. Y plus z. This call it equation number 1. For length, on this left hand side the exponent is 0. So here this is not 1, it is 0. For L, the left hand side the exponent is 1. The right hand side exponent is x minus 3y minus z. This is the second equation. For time, the left hand side it is negative 1. The right hand side it is negative z. That is the third equation. So solving these equations simultaneously, you get the value here, the value of z equals to 1 from third equation. Substituting this value of z in the first equation, you get y equals to minus 1 or negative 1. If y is equal to negative 1 and z is equal to 1, if we substitute in the third equations, you get x equals to 1 plus 3y plus z. That means 1 plus negative 3 plus 1. So you are also getting negative 1. Then you go back to this equation. Therefore, V velocity is equal to K R exponent x. X is now negative 1 times rho y. Y is also negative 1 times eta. Eta is z. Z is positive 1. So this is the same as K eta over R rho. So velocity of which the liquid ceases to flow with the streamline and start or begins flowing with turbulent is given by this formula. So this is the required relation. We quickly move to the next question. Question number 2, Part A, Roman 1, characteristics of projectile motion. Projectile motion is characterized by two perpendicular motions, the horizontal and the vertical motion, whereby the horizontal motion is moving with constant or uniform velocity and the vertical motion is moving with the uniform acceleration. And these two motions are independent. That means one motion does not affect the other motion in any case. Roman 2, explain the assumptions made when treating projectile motion. First assumption is that air resistance does not affect the motion or the projectile motion. So in other words, the air resistance is assumed to be negligible, has no effect. Another assumption number 2, the value and the direction of acceleration due to gravity is constant. That means when you are treating projectile motion, you assume acceleration due to gravity remains constant. Its value does not change, but also it is directed in one direction, which is downward direction only. The other direction will be treated as negative. If we assume this value of g to be constant, in other words, the effect of rotation and the shapes of the earth does not affect the projectile motion. So another person can state assumption that the effect of rotation of the earth and the shape of the earth does not affect the projectile motion. Okay, going to the next part. A body is projected so that upward path passes through the point x meter horizontally and y meters vertically from a point of projection. Show that if R is the range on the horizontal plane through the point of projection, the angle of projection theta is given. So Roman 3, we are required to show that theta equals to tan inverse of YR x bracket R minus X. So we are required to show that. So first, draw your X and Y axis. Then you draw a projectile motion with initial velocity v naught and angle projection theta. So the range, we have been given that there is a point in the projectile, point X here, point P is having X comma Y. That means the particle has covered a distance Y in the vertical and a distance X in the horizontal. And the range of projection in the horizontal plane in the horizontal plane is R. So what is important is that X from this point to this one, or from this point to that one, is given X is given by taking initial velocity cosine of theta times time taken to reach this point, the time from point of projection O to point P. And the distance Y, or from this equation, you can make time the subject. That means X divided by V naught cosine of theta call this equation number 1. And also, okay, 2B Roman 1. A bullet fired at angle of 30 with the horizontal hits the ground 5 kilometers away. By adjusting its angle projection, can one hope to hit a target 5 kilometers away? Assume the muzzle speed of the fixed is muzzle speed to be fixed and neglect air friction. Okay, we have been given target, that means range, equals to 3 kilometers, equivalent to 3,000 meters. Angle projection 30 degrees. Then we are asked if we want to adjust this angle projection either by increasing or decreasing. one can achieve a range of 5 kilometers. That means, can we achieve to get 5-kilometer range, which equivalent to 5,000 meters, by just changing angle? That is the question. So, first of all, by using the given range, we can find the initial velocity. Initial velocity, angle 30. We have this 3,000 meters. This is the maximum angle. Then from range equals to V naught square sine of 2 theta over acceleration due to gravity. V naught square is equal to Rg over sine of 2 theta. R being 3,000, G 9.8 over sine. Theta is 30, twice theta 60. So from your calculator, 3,000 times C divided by sine 60. Point. You're getting 94 8 point almost 2 meter per second square. After that, you check what is the maximum range. Maximum range by using this angle, this velocity, that is V square, implying that the V naught, this is meter square, under root of the answer, just 1.425 meter per second. Then the maximum range, R max, equals to V naught square over G. Then your V naught square is this one, 948.2 almost, divided by G. G being 9.8 meter per second. This is the meter square, second square. This is the meter per second square. Second square and second square cancel. You get 464.1 meters. But we are looking, given R2 is 5 kilometers, which equivalent to 5,000 meters. But here the maximum range is 3,464 meters, which is less than 5,000. So we conclude by saying, since the maximum range, which is 3,464.1 meters, is less than the one we expect to achieve meters, then one cannot hope to hit the targeting by adjusting angle. So maximum range is less than the required or planned distance. Therefore, one cannot achieve that distance. The next part, velocity at the maximum height of projection is half the initial velocity of projection. What is the angle of projection? So we have a projectile like this one. V0, this is the angle of projection. This is the maximum point. At maximum point, velocity is equal to V0 over 2. This is the maximum height. Then the question is, find the angle of projection, angle theta. From velocity at any point on the trajectory is equal to velocity along the horizontal plus velocity along the vertical. That's one. At maximum, point Vy is equal to 0, Vx is equal to V0 cosine of theta. Then V is equal to under root V0 cosine of theta square plus 0 square. You get V is equal to V0 cosine of theta. But this V is given to be V0 half. Therefore, V0 over 2 half is equal to V0 cosine of theta. V0 and V0 cancel out. Then a half is equal to cosine of theta. Then theta is equal to cosine inverse of a half, which will be 60 degrees. Therefore, the angle of projection is 60 to the horizontal. Moving to next question, part C. Two particles A and B are projected at the same time in the same vertical plane, whereby A is projected at height 2 meters above the ground, making an angle 30 with the horizontal. B is projected with the velocity 30 meters per second at the angle on the ground below A, vertically below A, making angle 60 with horizontal. If they collide together, if they collide. So from the given problem, we can sketch. First, we have this point. We have the ground, and we have this point, which is 2 meters from the ground. The particle is projected from this point A with initial velocity v naught of A at angle 30 degrees. Another particle is projected from this point v naught B at angle 60. So the two particles are projected simultaneously. After some time, they will collide at this point P. At the point P, both particles has traveled a distance y in the vertical direction and the distance xc in the horizontal direction. So the questions. Particle B is given the velocity equals to 30 meters per second. First questioning, what is the initial velocity v naught of A? Second questioning, time taken until they collide. And then the third questioning, the horizontal distance in the part of collision. So we are looking for x, v naught A, time to reach there, and the x. Roman 1, since two particles, so distance x of particle A is equal to v naught A cosine of theta times time taken by A, while the distance of B is equal to v naught of B cosine of angle B times time taken by particle B. But by looking this distance XA the same as distance XB, so XA is equal to XB. And because they are projected simultaneously, the time taken by this particle to go up to point P and the time taken by this one to go up to point P is the same. So TA also equals to TB. If that is the case, we equate these two equations. V naught A cosine of angle theta A, which is 30, equals to V naught B times cosine of angle theta B, which is 60, times T, of course T, times T. T will cancel out. Then V naught A will be equal to V naught B cosine of 60 divided by cosine of 30, of which V naught B is given 30 meter per second, cosine of 60 over cosine of 30. From your calculator, you get 17 meter per second. So V naught A is that one. Roman 2, what is the time taken by until they collide? So you can use another equation in which vertical distance for particle B is equal to vertical distance for particle A at P. So at P, y of A is equal to y of B is equal to y. Then y of A is equal to, because it is projected above, it is initial distance plus V naught of A sine of angle of A, which is 30, times T minus the half gt square. But y for B, it is projected from the ground, therefore it is V naught sine of 60 times T minus a half gt square. So because time are the same, this g and this g will cancel out. Therefore, h will be equal to V, this is the V naught of B, if I take this to the other side, it will be V naught sine of 60 minus V naught A sine of 30 bracket times T. So can you find T is equal to H, which is distance over V naught of B sine of 60 minus V naught of A sine of 30. If you substitute the values, T will be equal to 2 meters. This is the 17.4, is it 0.4? 17.32 cosine of 60, this is just a half, minus this is 30, this is the under root of 3, 30 over half. On the calculation, 17.32 sine of 60 so the V naught here, it is 30, this is 17.32. 30 times sine of 60 minus 17.32 sine of 30 times 2, you are getting the time equals to 0.115 second. So it will take 0.115 second to collide. The last is about x, horizontal distance. Roman 3 x can be calculated by using either of the particle, either particle A or particle B. If I use particle A, this will be equal to V naught of A cosine of theta A times time t. So this is equal to 17.32 cos of 30 times time, which is 0.115. Then you get this distance 1.73 meters. The next question, question number 3. Explain why acceleration is not 0 in uniform circular motion, but it is 0 in linear motion. Yes, it is true that acceleration is not 0 in circular motion, and it is 0 in uniform linear motion. This is because in circular motion, acceleration of a particle v, which is constant, is due to the change in the direction. At this point A, velocity is linear in this direction, but if we go to another point, it is also linear, but making degrees. So the direction at point A is different from the direction at point B. For that reason, then there is a net change in velocity here. Velocity here is not 0. So this change produces acceleration, and this acceleration is called centripetal acceleration, and it is given by velocity squared divided by radius. So if velocity is very large, also this is very large, but if radius is very large, this decreases. But for linear, because it is the straight, this point A, this point B, V here, V there. So acceleration here is 0 because the change in velocity is equal to dv dt. So V at A and V at B is the same. So that's why you are getting 0. So the main reason why the velocity, the acceleration in circular motion is not 0, despite the velocity being constant, is because of change in direction. Another question is, a load debunked so that there is no side thrust on the passenger. it take a curve with this 72 km/h speed. Find the angle of banking of a circular curve. If for the circular curve making 90-degree turn in a distance of, that is the Roman 2. So we have a banked road. We are looking for angle of banking, but we are only given the speed, which is 72 km/h, equivalent to 20 meters per second. Then we are asked to find, but we are also given the distance, arc distance. Arc length for 90-degree equals to 157 meters along the road. So while they are taking the turn, they have to travel a distance. It means if the enters, but this is a curve, if enters a road at this point, travel through 90, a distance of 157 meters from point 1 to point 31. So how this help us? Because it is a curve, but the question is asking the angle of banking. But here we are told the distance traveled. It means this distance can help us to find the radius of the curve only. So what to do? We start with what we are supposed to find. If we assume the surface to be smooth, then the velocity maximum or safe velocity equals to under root of rg tan of theta. Why we assumed to be smooth? Because we are not given any information of friction. So safe velocity for smoothly banked road is this one. So tan of theta, it means is equal to velocity square over rg. Velocity we have been given, g is known, r we don't know. That's why we have been given this information so that you can use this information to get what is r. Now, from circumference equals to 2 pi r. Then from A to B is not a full circumference, it's a part of circumference. So this will be equal to times the angle turned over total angle is supposed to turn, or simply equals to can be in a degree 90 over 360, or in a radian pi over 2 pi. 2 pi and 2 pi will cancel. So 157 equals to 2 pi bracket r times 90 over 360. Then r will be equal to, if I don't mistake, this is the 4, so it is a half. So it is just 2 times 157 divided by pi. Pi, which is equal to 3 times 157 over 3.14, which is equal to 100. So the radius is now known, it is 100. If it is 100, what will be now the angle? So the angle from that one, theta, will be equal to tan inverse of b square v, which is 20 square, over r is 100, and g is 9.8. From your calculator, you are getting 22.2 degrees, approximate 22 degrees. So the load should be banked at this angle. The next question. B Romani 1. Acceleration due to gravity is progressively less as we go towards the center of the Earth. Explain why. Acceleration due to gravity acting in two bodies. So as the body moves progressively towards the center of the Earth, it means the behind part of the Earth is also pulling that body in the opposite direction. So toward the center is pulling, behind is pulling. So the net acceleration will be decreasing. And at the center, what will happen? Because you are at the center, the force pulling you beyond, which is below and above, will be equal. So it means the net acceleration at the center of the Earth will be 0. That is the reason why it is progressively decreasing as you move toward the Earth. Roman 2, what will be the periodic time in hour of rotation of the Earth if acceleration due to gravity at equator becomes 0? Acceleration due to gravity is affected by a number of factors, one being the rotation of the Earth. Therefore, we know from acceleration due to gravity due to the earth is equal to g minus omega square radius of the earth cosine square of the latitude. So here r is the radius of the earth and this alpha is latitude. So if at equator latitude is equal to 0, so g is equal to g minus omega square r, where this g is the acceleration due to gravity average, which is the same as the acceleration due to gravity to the poles, which is 9.8. So if it will happen at equator, now this is 0 equals to 0, that means omega square will be equal to g over r, and that period will be equal to 2 pi bracket r over g. So you can calculate what is the period. R being the radius of the earth, g is 9.8. In your calculator, you get the answer. You get this 0.4006 seconds. Then you want to know this time in terms of hour. So you get 1.4 hours. That instead of now the earth rotating with the period of 24 hours, then the earth will start using 1.5 hours, or in short is 1 hour and almost 24 minutes. The next part, which is part 3, why there is no atmosphere on the moon. Atmosphere composes of air molecules, and these air molecules, they are moving at a certain velocity, and beyond or less than that velocity, the velocity of air molecule, which is called the root mean square speed of molecules, if is greater than the escape velocity in any body, surface, or planet, it means those molecules will escape. So to answer this question, that there is no atmosphere on the moon because the moon has a very, very low acceleration due to gravity, which is almost 1/60 of the acceleration due to gravity on the Earth. Because of this, its escape velocity, which is the square root of 2rg, is very small compared to the root mean square speed of the molecule. For that reason, the molecule will escape easily in that atmosphere of the moon, making that space around the moon with no molecules and hence have no atmosphere, because atmosphere are made with air, and air is a combination of gases. So those gases, they are not there. Then there is no atmosphere. So the main reason is because the escape velocity is very small compared to the root mean square speed of the molecule. And this value of escape velocity is small because of acceleration due to gravity, which is very, very small. The other part is a calculation. A stone projected a stone is projected of mass here attached to the end of the string of length 31 within around a vertical cycle. So we have a vertical cycle like this one with radius 10 meters. And in this cycle, the center of axis, it is at 20. So from there to the ground, 20 meters. Then this particle being whirled in the cycle, vertical cycle, it reaches a point where it breaks due to the tension. And this point is said to be at this one, with angle 60. That means when it's going up with the velocity v0. As a result of breaking down this particle, will go a projectile motion back to the ground. Then if I draw the parallel vertical line at this point and the horizontal, I'll find that this angle is similar to this one. Why? Because this is 90. This is 30. So for this to be 30, it means this also should be 90. If that is true, this is 90, this also will be 30, and this one will be, because of alternating interior and exterior angles. Then, what are the questions? So we have been given the mass of this particle to be 0.5 kilogram. The tension in the string T is equal to 700 Newton. So what are the questions? Sketch the diagram. So if it snap out, this will be the position at which this will plug. So that is the sketch. So you can even find this h is how much. From this point to this one, because we are given also the radius is 10, it means from this point to this one, it is a 10 cosine of 60, which is almost to be 5. So another will be 5 here. And from this point to this one is 10. So from this point to this one is 5. From this one to this one, it is 5 plus 10. So h is equal to 15 meters. So that is a sketch. what will be the initial velocity of projectile? V naught. We know that tension at any point is equal to mg cosine of the angle plus centripetal force. For this case, tension is 700. Angle here, mg, it is 0.5. G is 9.8. Cos of 60 plus 0.5. V square over radius, which is 10. Then you can solve for V. Solving for V, V will be equal to 700 minus 0.5 times 'So in total, you find that the initial velocity will be equal to 118.11 meter per second. Roman 2. Roman 3. The time taken to reach the ground. If it is the string broke at this position, then what is the time taken by this particle to reach the ground? So this will be time of flight. So because we have this h, we can use that equation. From time of flight, F equals to V naught sine of theta plus under root V naught square sine square of theta plus 2GH divided by G. We can find the time taken by this stone from this point to the ground. So this will be V naught, which is 118.11, then sine of 60 plus under root of 118.11 sine of 60 square plus 2 times 9.8 times h, which is 15, all over this divided by 9.8. If divide it, we will get a total value of 1 20.0 seconds. So the time taken 21.02 seconds. The next question, horizontal distance travel from this point to this one. This is x. This is the Roman form. X, of course, it is the V0 cosine of the angle of projection times time of flight. This is equal to V0, which is 118.1 cos of 60, time of flight 21.02. This will give us (41.38 meters). That will be the distance away from the point of projection or point of breaking. The next question, number 4, how will you distinguish between hard-boiled egg and raw egg by spinning each on the table? Raw egg is contain fluid inside it, but boiled one act like a rigid body because it is solid inside. So when you spin both on the table, the hard-boiled egg will spin faster than the raw one. Why? Because it is acting as a rigid body, therefore can spin faster because of mass distribution. But for raw egg, liquid tend to go away from the axis. It means distribution of egg or liquid inside the raw egg will be far from the axis of rotation. As a result, moment of inertia will increase because the mass will be distributed far from the axis of rotation. And if moment of inertia increases, that means spinning rate will decrease because moment of inertia is the measure of how difficult it is to cause something rotate. So by spinning, you can easily distinguish because the hard-boiled egg will spin faster while the raw egg will spin less. If I go to the next part, briefly explaining why moment of inertia of a given body is not unique. Yes, moment of inertia depends on the mass distribution from axis of rotation. That means if I change the axis of the same body, still the moment of inertia will be different. So, for example, if I have this meter rule, if I choose the axis to be at the center, I'll get its moment of inertia at the center maybe equals to 1/12 mass length square. But if I shift this axis to the end, moment of inertia of the same meter rule will be different. This time I'm going to have moment of inertia maybe 1/3 mr square. So the same rule, meter rule, but different moment of inertia. This is because if you change axis of rotation, mass distribution also changes. So it is not unique because it depends on mass distribution from the axis of rotation. The other one is B Romani 1. State the perpendicular and parallel axis theorem. Perpendicular axis theorem states that the moment of inertia of the body about the axis which is perpendicular to the plane. Remember, perpendicular theorem is for only plane body. Plane body. Plane body like a disc, laminar, and similar like that, or things like those. So the moment of inertia of axis, which is perpendicular to the plane, this is the plane of the body, is equal to the sum of moment of inertia of mutually perpendicular axes which lie on the plane. That means if I have two axes which lie on the plane, maybe this is x, this is y, this is z, then z is perpendicular to the axis, the plane on which axis y and x lie. But this x and y also they are perpendicular, and this axis z intersect them at this point of perpendicular. Then the moment of inertia of z is equal to moment of inertia of y plus moment of inertia of x. That is a perpendicular theorem. The parallel theorem, this is general used for all bodies, whether plane or three-dimensional body. Here the parallel say if you have the moment of inertia of the body about this axis parallel to the axis passing through the center of mass of the body. So this is center of mass. Then the moment of this body, this body about this axis will be equal to moment of inertia of the same body about the center plus the product of mass and the perpendicular distance between the two axes. So here is the perpendicular distance between the two axes. Moment of inertia of this body about this axis, which is parallel to axis through the center of the same body. Then this moment of inertia of this body will be equal to the moment of inertia of the body about the center plus the product of mass and the perpendicular distance between the two axes. Roman part B, Roman 2. Calculate the moment of inertia of a thin disk of mass 0.04 and radius 0.0 rotating about axis along the diameter. So we have a disk of diameter, maybe or radius. So there is the axis perpendicular to this disk, call it Z, but there is also axis on the disk, call it I, along the diameter. But diameter have the same distance, that can have another diameter there. So this is also axis. So this disk can rotate about the vertical axis passing through the plane, or it can rotate about this diameter and this diameter, but they intersect at the center. So by looking the two axes on the disk plane, they are perpendicular to each other. And the one which is vertical to the plane is also perpendicular to this one. So this is the ID. So I can, from perpendicular theorem, perpendicular axis theorem, the moment of inertia of axis which is perpendicular and intersecting the other two mutually perpendicular axes on the plane, ID plus ID. But ID and ID are the same. So ID will be equal to twice of ID. Then the question is asking me to find the moment of inertia about D. So I can make ID the subject, ID over 2. But IZ for a disk, it is a half mass times radius square. Therefore, ID will be equal to 1 over 4 mass r square, which will be mass is 0.0. Mass is 0.04 kilogram, and the radius is 0.05 square, you get meter square. So this will be equal to 2.5 times 10 exponent 5. This is 0.66 plus, so 5 kilogram meter square. You can check on your calculations. Times 0.05 square divided by 4. Yes. That is the moment of inertia of the disk about the axis along the diameter. Going to part 3. A wheel and axle are made to rotate about the horizontal axis with the help of a body of mass 5 kg attached to the string wound around the axle. The radius of the axle is 10 centimeter. The body falls vertically through 5 meters in 10 seconds. Starting from rest, calculate the moment of inertia of the wheel and axle. So, in this case, So in this case, we have a wheel and there is an axle mounted on it having a radius r. So there is a string wound around this axle and then attached to the what? To the mass. That means due to tension of mass on the string, this an opening and the mass accelerates downward through a distance of 5 meters. So the question is, what is the moment of inertia of this system of wheel and axle? Of course, if there is weight there acting down, it means net acceleration downward can be calculated. So for that reason, from mg minus tension equals to ma, which is the acceleration. Then the tension equals to m bracket g minus a. That is the first equation. And also, due to inertia, there is torque that causing the turn is equal to force times the perpendicular distance. Our force here is the tension, which is equal to mass. So it's equal to tension on the string, and the distance perpendicular, which is making 90 degrees there, it is radius of the axle. But this also is equal to moment of inertia times the angular acceleration, or angular acceleration, which is equal to linear acceleration over radius. So from these two relations, you can make T the subject by equating this one is equal to moment of inertia, linear acceleration of radius square. This will be the second equation. Then if you substitute it in the second equation, you will find that moment of inertia A over R square is equal to mass G minus A. Yes, G minus A. So moment of inertia equals to mass times radius square G minus A over A. Simply, moment of inertia is equal to mr square bracket G over A minus 1. So the problem here is A. So we cannot get the moment of inertia of the system. So how are we going to get this value of A? That's why we are given the other information in 5. So as it accelerates down, has covered a distance of 5 meters in 10 times. So which equation which included distance and the time is the second equation. So from second equation, S equals to ut plus a half at squared. At squared. Then our h here, it is 5 meters. U, it is from rest, so it is 0. Therefore, A will be equal to twice of S divided by T squared. So 2 times S is 5 meters. Time, it is 10. Square, you're getting 0.1 meter per second square. So after getting acceleration, now you can go back in question number 4. Is it number 4, number 3? To find the moment of inertia. So moment of inertia I equals to mg. M, it is 5 kilogram. R is 0. R, it is 0. It is 10 centimeters, so 0.1 square bracket 9.8 over 0.1 minus 1. This you get 4.85 kilogram meter square. because the unit of acceleration and the unit of acceleration cancel out. So on a meter square and a 5 kilogram. Part C, Roman 1. For C, Roman 1. Action and reaction forces are equal and opposite. Explain why don't they cancel each other. Yes, it's true that the action and the reaction they are equal in magnitude, but they act in opposite direction. But these two forces, they don't cancel out because they acting on different body. That means you are kicking the ball, but the ball, you are impacting the force on the ball, and the ball impacting the force on you. But mass of the ball is small, then it will accelerate more than you because you are massive. So the reason because they do act on different bodies. That's why they don't cancel. In simple language, they produce different acceleration. Roman 2, we have been given the plane. One with angle 30 degrees, the other one with 45. We have two masses passing through the string. So we know that this is mass 2, this is mass 1. Therefore, there is a friction force. First of all, there is tension here, the same as tension there, because it's a single string connecting the two bodies. Then there is a friction force 2, and there is a friction force 1. But the direction of motion of this system of connected body is not indicated, so you can choose your own direction. If you choose is going down the M1 is going down with acceleration A, that means this one is going up with acceleration A. If this one is going down with acceleration A, it means this is going up. So if we choose this is going down, it means here friction force will change its direction, because the friction force is there to oppose the motion. So friction force FR2 will be this way. And this one, because is going down with mass M1G sine of 30, this is going down with mass M2G sine of 45, then the friction force here will be opposing. After that, you consider one mass at a time to find its equations. If we start with the mass 1 is accelerating downward. Therefore, the net equation M1 G sine of 30 minus the friction force which is opposing the motion will be equal to the net force of this mass. So this friction force, the friction force is the same as coefficient of friction of mass 1 times R, equals to R being the normal reaction. Again, R which is perpendicular, this will be R1, perpendicular to this one, if you equate this, R will be equal to M1 G cosine of 30. So on writing, you find that M1 G sine of 30 minus mu R M1 G sine of, cosine of 30 equals to M1 A. So you can see M1 can vanish out and leaving G on sine of 30 minus mu 1 cosine of 30 equals to A. So because I've forgotten one term here. This is tension. This is the force minus tension. Minus tension minus tension equals to this one. So this minus tension equals to M1 over, this is MT. So instead we can just write M1G minus tension, this is the bracket, equals to M1A. If we substitute the value of M1 and G plus mu, what is the mu1? M1 is 6, 9.8 sine of 30 minus mu1, it is 0.3, then cosine of 30 minus t equals to 6a. Cosine of 30 equals to this one times 0.3 equals to that one, 0.5 minus the ounce equals to this one times so you're getting 14.12 minus t equals to 6a. That is equation number 1. For mass 2, you do the same, but the only thing will change here, mass 2 is accelerating up. So tension minus everything here will be equal to that one. So this mass 2 tension minus M2G bracket, that is sine of 45 plus mu2 cosine of 45 equals to M2A. If we substitute the value of M2 and the mu2, you get tension minus 9 times you get 74.22 2 equals to 9a. That is the second equation. Solving the two equations simultaneous. Solving the two equations simultaneously, you get A equals tension equals solving simultaneous. The method that difference is the substitution, elimination, graphical, but you can also solve by using calculator like I've done. But for calculator, you need to put variable one side. That means first equation you can write t plus 6a equals to Take this t to the other side, equals to 14.123. The second equation, you start with t, then this will be t minus 9a equals to negative or positive 74.22. Then you can solve. Or if you minus these equations, you get 15a equals to negative 60.097. So A will be equal to almost 4.006 meter per second square. And then you can go back to find the t. So t will be equal to 74.22 plus 90 times negative 4.006. Then you get 38.16 Newton. So the negative here indicates that the direction you have chosen is opposite to the real direction of motion. That means the particle is accelerating upward in this direction downward. So lastly, you conclude that the acceleration of the system is equal to 4.006 meter per second square. The next equation distinguishes between periodic motion and the oscillatory motion. The difference between periodic motion and the oscillatory motion is that the periodic motion is the motion that repeats itself after a regular time interval. But oscillatory, it is also a periodic time, but this motion is a to and fro motion about mean position. It means it is periodic, but is a motion along the linear line. It goes and back, goes and back through a certain center. But periodic can be rotating, not necessary to take the same path. So oscillator is linear, but periodic, because after it has gone to this end, it will come back and repeat again the motion. So it is periodic. But periodic generally can be, not all periodic motion are oscillatory motion, but all oscillatory motion are periodic motion. So the only difference, this is the periodic about a certain point in a linear direction. This is a general. Roman 2, a particle moving with sympharmonic motion has a velocity of 1.8 when passing through the mean position. and the acceleration at 0.8 from the mean position is this one. Find the amplitude and the period of the oscillation. So we have been given the velocity at the mean position is always maximum. That means we have been given the maximum velocity 1.8 meter per second, and also we have been given at a certain position which is 0.6 from the mean position. The acceleration is equal to 2.4 meter per second square. Then we're asking for amplitude and the periodic time. So to solve this, we know that from velocity equals to angular velocity under root of amplitude square minus the position square. Then at minimum or at mean position, this is 0. So V max will be equal to omega A. So we're looking for what? For A. A, it is V max divided by omega. Omega being the angular velocity. But we don't have omega, we have V max, so we cannot find the answer. We write this question number 1. We go back to the other information. We are given positioning or displacement and acceleration. Which equation connects the acceleration and the displacement? From acceleration is equal to negative omega square y, the magnitude of this of this A will be equal to omega square y. Then what is the value of omega? Omega square will be equal to A over y. That means omega is equal to under root of A over y. So here you can find omega. A it is 2.4 and y it is 0.6. So you find that the omega is equal to 2 radian per second. If omega is equal to 2 rad per second, then you go back to equation number 1 to find the amplitude, where amplitude is equal to maximum velocity divided by angular velocity, which is the omega. Therefore, amplitude is equal to 1.8 divided by 2. So you're getting 0.9 meter. And for period, from omega is equal to 2 pi over period. Period will be equal to 2 pi over omega. That means 2 pi, omega is 2. 2 and 2 cancel out. So therefore the period will be equal to pi, which will mean 1.1 seconds. And this